My name is Keith Johnson. I am the program lead of mechanical engineering, and when you go from the pathway from ICD into level 3, I will see you there and I'll welcome you onto the program. So Corinne mentioned a little bit about the subjects that you will study in ICD. So these have been directly mapped onto our level 2 engineering program, and I can give you an example of some of the subjects that you would study and the knowledge that you need to know as a mechanical engineer. So we have some general engineering modules that you need to know, for example, in electronics, programming. We have some core modules in mathematics, but we have also a lot of project elements. And project element is the fundamental key thing for mechanical engineering, where we learn mechanical engineering skills by completing a practical project. So an example here, we have a practical project for manufacturing project, it's called. It's a module where the students actually get to design a mechanical clock. That may sound quite easy to do, but in fact, it's actually quite a hard task where they've got to design all of the cogs, they've got to put it together to be a functional prototype, and the actual design has to keep time for over 2 minutes. So it's actually quite a hard thing to do, but it's just an example of a practical project. We have other dedicated equipment, for example, in thermodynamics, where we can use some practical experimental or lab kit to complete some workshops, also for fluid mechanics as well. So we've got a lot of dedicated equipment that ICD students will have access to, and also complete the same experiments that the level 2 mechanical engineering students would as well. One thing about mechanical engineering at Dundee is that we're very strong in computer-aided design. That means we're very strong in completing CAD models, which is essential really to be a design engineer when you graduate from your degree. So you have to keep that in mind for the graduation perspective of what are the key skills you're going to learn in these programs. So we're very, very strong in CAD design, where we use an industry recognized software known as SolidWorks, where you begin to design individual models. You can see some examples here of some robotic hands, some helicopters, some automotive, where you design parts and put them together to make a functional assembly, of which then you can go and you can create engineering drawings, for example. But one of the things that we're unique about Dundee is that we're a centre for accreditation in SolidWorks. That means that the students who go on to this program, and this is the same for ICD students, will be able to have access to an optional exam, which is an accredited exam, where if you pass it, you will get an industry recognized standard for design, which makes you a little bit more employable than a lot of other students perhaps who haven't taken this exam. So it's a really excellent thing to do for yourselves. We're also very strong in simulation and software and understanding how to use software for industry. So in SolidWorks, you can design and we can create designs where you can create a motion study, a stress study, and a finite element study. You can do heat transfer studies, for example, it gives you the kind of idea of things that you will learn as well. The other side of creating things in CAD modeling is really to create the electronic side of things, where we want to create a microelectronics. So we're very strong as well in microcontrollers, where you begin to understand about how to create a prototype. So how to create an input, for example, such as a sensor, such as sound or light or touch, and how we can create a system to have an output, such as movement, for example. And we do this in this module as well. It's software applications for engineering design. As mechanical engineers, you need to know about engineering materials. So it's a key subject that you need to know. We have a lot of dedicated equipment whenever you come into level 3, for example, where we can carry out some specific experiments in relation to creep, tensile testing, for example, where you have a material, you can pull it apart and you can get some more information about its material properties, such as the stress and the strain. We have a lot of dedicated equipment for that. One thing that's a bit different between the mechanical engineering and mechanical engineering with renewables is the modules that you'll take in 3rd and 4th year. So with the renewable students, you'll take specialized modules that makes you a little bit more employable inside the renewable sector, as well as the mechanical engineering sector. With the renewable modules, we take a solar energy, water resources and management, wind and marine energy, and electrical power on the grid. That's to do with hydroelectricity. And these modules, along with mechanical engineering in 3rd and 4th year, makes you specialized in that field. I would say Corinne mentioned that we are accredited for the MECE, so the level 2 is going to be accredited. ICT level 2. Also the core program as well is accredited by the Institution of Mechanical Engineers. That means that they've looked at all of the learning outcomes from the 3rd and 4th year in all of the levels and said the students that are graduating from this program are really excellent students, and they can gain employment in a large range of fields inside of engineering. So it's very, very employable. That's one of the great things about mechanical engineering, and also with the renewable side of things. And just to say, with renewables, it's becoming very, very strong in Scotland. So there's a lot of jobs within renewables in Scotland, and if you've noticed on the TV, I mean, the renewables, electric cars, transport, the drive from legislation side of things to create jobs in industry for renewables is very, very, very strong. So we are an accredited degree, and actually there is an opportunity for students going in between the 3rd and the 4th year to go and visit industry, so they can have an industrial placement anywhere in the world. So if you're interested in going to industry between 3rd and 4th year, we will support you for that. So we have a couple of specific partnerships, such as a partnership with CERN, where you could, at CERN, that's a Large Hadron Collider, perhaps maybe heard of that in Switzerland, where you have the opportunity to go there. There's 5 or 6 placements for students on our program, which are quite competitive, but it is an opportunity for you to do that as well. And we have other exchanges, for example, with China and Europe as well, other opportunities. 3rd year is whenever you come into the program, we're very much engaged with industry in 3rd year. So you've learned all of your general engineering skills in level 2 with ICT, and in the 3rd year you get to practice those with industry. So we have what's known as a problem-solving industrial visit, where you get to go in small groups of 6 to a specific company, and we have a large industrial advisor board where they set you a specific problem to solve. So you go away, you go to the company, you get a tour of the company, you meet the boss, and he sets you the problem to solve. In teams, you go away and you search solutions, you create prototypes, you create CAD models, and after 10 weeks, you go back and you present your results to industry. So it's a chance for you to show the industry what it is, what's good about your project, what's unique, what you designed and created. So it's an opportunity for the students to engage, and it's very, very popular with the students. It always has been, and I really enjoy it personally myself as well. So the Industrial Advisor Board is part of that journey where the students go and visit these types of industries. You may recognize, so it is an opportunity for students to engage. So just to touch on some of the softwares that we do have within the program. So we are quite keen on the softwares and combining that with the practical elements. So engineering design, we get in 3rd year a little bit more advanced prototyping. So this to do with embedded systems and microcontrollers. And you can see an example here of a C language program. So don't worry if you do not understand programming. This is a fundamental learning process between ICT and level 3, where the students will gain all of the core knowledge to be able to complete the programming in level 3. And this is also working in groups, which is very, very key as well. So you get support with your other group members. If you do feel like coding is can be a harder task for you. Some students pick up coding very, very well, and that's really, really great. But don't assume that you need the knowledge, great knowledge to get into level 3 and complete this project. So next slide, please, Dice. Engineering design for 3rd year as well. We have a specific software we use, Design Spark, where you can begin to create printed circuit boards, schematics. You can see some examples here where we have dedicated equipment to be able to do that. So this is combining now with the microcontrollers. In the software skills, we have got a robotics module in level 4, where we could begin to learn about MATLAB and simulations. We have practical workshops here for robotics, where you can see end effectors and the movement. End effectors versus a reality. In Honours Year project, we also augmented and virtual reality, very much used in industry these days, where you can begin to design using holograms. For example, you can put on a headset and you can present a hologram, where you can design in real time with the hologram, or indeed an immersive technology such as virtual reality, where you can design in an enclosed space. Very much used in industry and very much a key skill that we begin to learn about. And you can do this in your honours project, for example, or simulations as well for finite elements, CFD. So you can see some bicycle frames here that have been simulated airflow over. You can optimize the bike frame design. You can go backwards and forward and see how your design has changed the stress and the strain, for example. Lots of different projects. So this is just a small sample of some things I'm interested personally, but within the honours project list, we have many academics and a large range. And it's also a chance for you to complete your own project at this time. So some students, if they get an idea through their studies, they want to do that in their 4th year, now is the time to do it. And I really do emphasize that as a good thing to do for your own interest over both semesters. Also, last slide, thinking to do with software, or second last, ANSYS, very much used in industry as well. If you want to become a simulation engineer, we have specific modules in 4th year for level 1 and 2 for CFD and FEA to simulate stress and strain, and we learn about that in this specific module. LabVIEW, control and dynamical systems. Yes, indeed, a very core concept as well, where if you create a device, you need to be able to control it. So you need to understand how to do that. And we have dedicated equipment, lab equipment for vertical takeoff and landing, pressure and vibrations, and inverted pendulum, for example, for you to create a program using the front panel in LabVIEW and understand control and dynamical systems. So it's a key core concept as well for mechanics. So CERN, we mentioned that briefly. So we have got the Large Hadron Collider in Switzerland here, and CMS detector. You may have seen on the news recently that they've started up CERN again, where they've recently created an experiment. But we have a partnership between 3rd and 4th year, where the students can go there for a year long. Actually, it's through the Turing Mobility Award, and it's funded placement, but there's only a few of them, it's 5 or 6, so it's quite competitive. So, but it is an opportunity for you to do that at the world's largest research experiment. So it's a great thing to be connected with the program. Last thing. So talk about the Formula Student Team. So Formula Student Team at the university, we have got our own Formula Student Team, and the idea is where they begin to design and race a single-seated race car, and they bring that down to the universities in Silverstone in July and race against other universities. So it's a societies run by students, and it's an opportunity to get involved to build this car. And we have dedicated workshop inside of the engineering building here, and you can see some of the students. A car actually was raced a few years ago, where they created it very quickly, and they brought it and they tested it in Lookers and competed against the other universities. So it's a very fantastic opportunity for you to get involved in. I think that may be it. Oh, one last thing is to do with the rest of the societies within the university. So we have, within mechanical engineering, we have the drive team. We also have the Aeronautical Society, where it's a chance for the students to build an autonomous drone, so it has to take off and land by itself, which is actually quite a hard thing to do. The students have been very successful in that in the last few years. Indeed, they were 2nd in Scotland and 5th in the UK. So it's an opportunity again for you to get involved if you wish to. I think that's maybe it, guys. Yes, welcome too. So yes, thanks very much for that presentation.